Hello everyone, I am Dr. Naresh Kumar, Assistant Professor in the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are going to have a discussion on definitions and terminology on inverters. So what do you mean by inverter? Here total we have in the inverter total 15 questions. So in that first question, this is fifth module. So first, what do you mean by current source inverter? Next, voltage source inverter. What do you mean by inverter? Inverter is a DC to AC converter. So which converts from DC to DC or direct current to the AC current. So here in that there are two types of converters, current source inverter and voltage source inverter. If you see the definition for current source inverter, so it is a kind of DC link converter which is two-stage conversion device with current in one direction and voltage in two directions. So what is the difference between voltage source inverter and current source inverter? This is, you can call it as CSI, or the voltage source inverter you can call it as a VSI. In this case, output voltage is constant. In this, output current is constant. So now if you see describe the voltage source inverters. So voltage source inverter means here voltage source inverter is also DC link converter, which is two-stage converter, same thing, with voltage is in one direction and current in two direction. In the previous one, current source inverter, so current in one direction and voltage in two directions. See the definition. If you see this one, so current in one direction and voltage in two direction. In case of voltage source inversion, the voltage is in one direction and current is in two directions. So now here commutation of the current source inverter. Commutation means the process of turning off. So now here the commutation of the inverter is a load dependent. It's the commutation is depending on the inverter commutation is depending on the only load only. So the load parameters from a part of the commutation circuit. So inverter must necessarily to be a forced commutation one. So it must be a forced commutation, not natural. Next, define pulse width modulation. Pulse width modulation is the process in which the signal is transmitted by the pulses with a special technique, that is pulse width modulation. Inversion. Inversion means DC to AC. Rectification means AC to DC, which converts from DC power to the AC terminals. So this is inversion process. Rectification process means AC to DC. So that is in rectification, inversion. Describe series inverter. So in the series inverter, commutating elements L and C are connected in series with the load in order to provide the commutation. So now here this forms a series RLC resonating circuit. So now here this is the thyristor, and next this one is a supply, this is load L, and this is C, and this one, and there is another commutator, another thyristor T1 and T2. So here this is the load, this one is the load. So now here commutating elements L and C are connected in series with the load. Here load is the R in order to provide the commutation. So this is the commutation process. So now here this is known as the RLC. RLC are connected in the series. So what about the parallel commutated circuit? Here during the working of parallel commutated, capacitor comes in parallel with the load via transformer. The parallel elements provides commutation in this circuit. So in the parallel commutation circuit, so C comes in parallel with the load via transformer. Next, what do you mean by ideal switch? So ideal switch is a switch which does not consume the energy or power, or which dissipate which does not which is not dissipate any power from the source. So now if it is a source, suppose here, so now if suppose thyristor is a switch, so now it should not be it should not consume any type of energy, or it should not dissipate any type of energy. So such type of switches are known as a ideal switches. So now ninth one, describe forced commutation in the inverters. So describe the forced commutation in the inverters means half wave inverter circuit. The forced commutation is essential when load is resistive because no natural occurs. So now here in the half wave inverter, this is DC T by 2, and next another one is in this. So here forced commutation is compulsory in case of half wave inverter circuit. So in some other circuit, so natural commutation is possible. Define total harmonic distortion, THD. THD means here total harmonic distortion is the ratio of THD equals to ratio of RMS value of all harmonic components to RMS value of fundamental components. This one. Next, describe variable voltage and variable frequency. Variable voltage means control of frequency and control of voltage in three-phase inverter possible through inverter control of frequency and through control of voltage only. Describe 120-degree mode of operation. The 120-degree of mode of operation. So now here only in the diagram I will show you first here. Let me change the color. So now this is the diagram for 120 degrees mode. This is one. This one and this one, and next this is connected across the load VDC, and next load is connected to this one. This is connected to, sorry, this is star connection. So now here this is the load, and this is T1, T3 and T5, and next T2, T4 and T6. So now here in this case only in the at a time only it conducts, only two conductors will two thyristors will commute. So two thyristors will operate. So now if you see the control scheme of this 120 degrees mode, here this is this one 0, 60, 120, 180, 240, next 300 and 360. So now here in the first leg here T1 and T4 will operate. So first leg, so up to this is 180. So in the 120 degrees, T1 will conduct up to 120, and next here this is 120 degrees mode of operation. One thyristor will conduct only 120 degrees operation. So now T1 will conduct for 120 degrees So up to here 120, and next remaining it will not work. And after 180 degrees case, T4 will conduct. So next here this is up to 120 degrees. Next up to here no thyristor will work. And next case, next T1 and T4 over. Next T3. T3 is here. So T3 starts from here and up to 120, and this there is no thyristor. And next this is T6. Next thyristor is T6, and this is T6 60, and there is a 60 T6. So this will not work. And after that, next case here T5. T5 will operate at 240 plus 120, and next here it will not work. And next here T2 will operate and it will conduct only, and it will not work. So this is the control scheme of the 120 degrees mode of operation. So now here at a time only two thyristors will conduct. So T1 and T6 between 0, T1 and T6 between these two, and T1 and T2 60 to 120, and 120 to 180 T3 and T2, and next 180 to 240, so T4 and T3, and next 240 to 300 T5 and T4, T4 and T5, next 300 to 360 T5 and T6. Again this cycle rotation. So after that, according to this scheme, you can determine the output voltage. So now 180 degrees mode operation. So at a time 3 thyristors will conduct. So at a time 3. So how it will work, I will explain in the next slide. So now in the 180 degrees mode of operation, so first here, so 120 degrees mode of operation, each electronic device conducts only for 120 degrees, and it is suitable for delta connection in a load, and 6 step by step of waveform or any phase, and at any instant at two thyristors are only conducts, because the devices are conducts at 120 degrees. 180 degrees mode of operation. In the 180 degrees mode of operation, so every device is conduction state for 180 degrees, where they are switched on at 60 interval, and terminal A, B, C are the output terminals of the bridge, and they are connected 3-phase delta connected. So now again I will draw the diagram. So first is this is the this one. This is the diagram. So now here this is DC, and next this is T1, T3 and T6, and T2, T4 and T6. So this is T5. Same control scheme. (60, 0, 60, 180, sorry, 120, 180, next 240, 300 and 360. So now here this is connected to the load. So now here, so first here between at a time 3 thyristors will conduct. So now I will explain. First T1 will conduct here. T1 will conduct up to 180. So T1 will conduct up to 180. After that T4 will conduct up to 360. Next T1. Next 120 degrees case, 120 degrees. So 120 degrees T3 will conduct. T3 will conduct, and next T6 will conduct. Next, this is T6. This 6 up to here. Next case, T5. T5 will start at T5 and up to here T5. Next here, this is T2. This is T2. So now here, if you see the control scheme here, at a time 3 thyristors will conduct. So 0 to 60, T1, T6 and T5 will conduct, and next between these two, T1, T6 and T2. And next between these two, this one, T2, T3 and T1, and between these two, 180 to 240, T2, T3 and T4, and 240, T5, T3 and T4, and 300 to 360, T5, T6 and T4. According to this control scheme, then we can determine the output voltage of 180 degrees more. Next, sinusoidal pulse width modulations. If you see the definition, so PWM, sinusoidal PWM pulse width modulation waveform is obtained by comparing the desired modulated waveform with a triangular waveform of high frequency, regardless of whether the voltage of signal is smaller or larger than that of carrier waveform. Resulting output voltage of the DC bus is either negative or positive. Next case. Next case, multiple pulse width modulation. In the multiple pulse width modulation PWM technique has numerous number of outputs that are not the same in the value, but the time period over which they are produced is constant for all outputs. Inverter with pulse width modulation PWM are able to operate at high voltage output. So total 15 questions, 15 definitions and terminology. So main thing here, main important, 120 degrees conduction mode and 190 degrees conduction mode. And next thing here, series inverter, parallel inverter. Next here, inversion definition, pulse width modulation definitions, and next here current source inverter and voltage source inverter. So all these are important. I hope all these definitions are clear to you. If you still have any doubts in this lecture, you can comment in the comment section below. I will answer to your query. Thank you very much to you all.
Like, share and subscribe. Hit the bell icon for more updates.